Okay, let's look at the last example. Now, this picture here shows you perfectly how volume and pressure are related. Now, if you look at this plunger or injection, you know that when you push the plunger in, you are actually exerting pressure on the plunger. And as you're exerting pressure, pushing it inwards, you can see that this space here is getting smaller. This space where A is getting smaller, which means if the space is getting smaller, the volume is decreasing, because volume is essentially how much space something takes up. So as you're increasing pressure, volume will decrease. And if you're doing the opposite, so if you pulling the plunger out, you are actually decreasing pressure. And as you're decreasing pressure, the space here of A will become bigger, which means volume will become bigger. And that shows you how volume and pressure are inversely proportional to each other. Right, now let's look at the question. It says here, a sealed gas syringe contains 80 centimeter cubed of air. Now, if you're looking at centimeter cubed, anytime you see a cubed, it means volume. So cubed is just like how you see it in maths. Volume is always cubed. So same thing here. Every time you see something cubed, whether it's centimeter or decimeter or meter cubed, if it's cubed, it is volume. Right, the plunger is airtight but can move freely. The atmospheric pressure is 100 kilopascals. So here they gave us one volume and one pressure. Now remember, when we're using Boyles law, we need to either have two volumes or two pressures depending on what they're asking us for. Right, let's look at number one. What is the pressure of the gas in the syringe? Now, they just told us it is 100 kilopascals is atmospheric pressure, which will be the same as the one in the syringe. So it's just 100 kilopascals. Okay, number two. What additional pressure must be exercised on the plunger so that the air is compressed to a volume of 50 decimeter cubed while the temperature remains constant? Now, when they tell you the temperature remains constant, they're actually giving you a hint that it is Boyles law, because pressure and volume are inversely proportional when temperature is constant. Okay, now they're asking us here for additional pressure. They're not asking us for the pressure afterwards, which is P2. They're asking us for additional pressure, which means we're not going to work out P1 or P2 only. We are going to work them out, and then we're going to find out how much extra pressure was added to what we had originally, and that will give us the additional. So basically, we're finding the difference between P2 and P1. Now, can you see they gave us a second volume here? Now, this volume is actually a mistake in the textbook, because remember I told you need to have two units that are identical so that you can cancel it out. Now, here they gave us centimeter cubed and here they gave us decimeter cubed. But because it's a mistake in the textbook, we're just going to change this to centimeter cubed also. Okay, so just do that in pencil. And now, since they both centimeter cubed, they will cancel each other out, so it really doesn't make a difference. Okay, so now we are going to solve for pressure, and we're just going to use Boyles law. P1 V1 is equals to P2 V2, and from here it's just as simple as substituting. Now P1 is what we had first, which is 100 kilopascals, so there's 100. V1 is 80 centimeter cubed, so you will solve in 80, and V2 is 50 centimeter cubed, so you will have 50 here. And then if you solve for P2, this will give you 160 kilopascals. Now remember, we said you don't need to change units. Whatever units you have, you must have that units before and after. So because we had pressure with kilopascals before, P2 will also have units of kilopascals. Now, the question didn't ask us what is P2 or what is the final pressure. They asked us what is the additional pressure, which means in the beginning, they said the pressure is 100 kilopascals, and since we found out P2 is 160, it means additionally we added 60 kilopascals to that 100 kilopascals to give us 160 kilopascals. So the additional is just going to be P2 minus P1, which will give you 60 kilopascals.